Hello everyone, welcome back to ptet.chemistry channel. So in this continuation of this year 11 revision on inorganic chemistry and the periodic table, I'll be talking about this set of questions that specifically cover group 1 metal chemistry. So group refers to the vertical up and down. So we're looking at group 1 where it labels with the Roman numeral 1 up there. So you will have lithium, sodium, potassium, rubidium, cesium, etc. So rubidium is below potassium, that is the information given. State the formula of the rubidium ion. So being a group 1 metal, all of them will have 1 electrons in the outer shell, such as what I'm showing you on the screen right now. 1 electrons in the outer shell, blah 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 blah, something 1 in the outer shell as well. So therefore, when they form ions, the metal loses electrons and they will form a singly charged cation, meaning to say they will form positive ion with a +1 charge because group 1 metal loses 1 valence electron and therefore you get a +1 cation. Rubidium and potassium both react with cold water, so very reactive metal. So how different would they react? So this question is not why or how they are the same, but this is different. So we can say that rubidium is below potassium and therefore the outer shell is easier to be lost. If the outer shell is easier to be lost, rubidium reaction will be a lot more reactive. Difference in the way that they react. So rubidium would react more violently. It would react more vigorously. So essentially you want to highlight the fact that the reaction is a lot more reactive. So you say more violently or more vigorously. Both of these would imply or would suggest that rubidium is a lot more reactive than with potassium. Somewhere along that line, straight to the point. Okay, now state the products because this is a metal plus water, or reactive metal plus water. Reactive metals like group 1 metal plus water, you will get metal hydroxide and also hydrogen gas. However, they say state the products, so usually we give the name, but because they don't say state the formula, if you give the formula, I don't see how they will be wrong because they don't say name the products. So you could say rubidium hydroxide, or you could give the correct formula if you know how to get to the correct formula. That would have been alright as well. Because of Rb plus, we have OH minus, it will be RbOH. This will be H2 and not H because hydrogen exists as a molecule. In this next question, so again, they are all elements in group 1 chemistry. Outermost shell mean valence shell. So how many electrons are there in the outermost shell? As mentioned previously, all the group 1 metals, group number tells you how many electrons are there in the outermost shell. Group 1 meaning they all have 1 electrons. Okay, use the word 1 electron, choose whichever one and you can just get that 1 mark straight away. Next one is describe the trend, not explaining. They are not asking for explanation. They just want what happened to the trend in melting point going down this group 1. So down group 1, this is a stating kind of question, a factual kind of question. We can say that the melting points decreases, or the melting point decrease, but it has to be decreased down group 1. So basically lithium to sodium to potassium, rubidium, cesium, the melting point decrease down group 1. All of them react with cold water, at least lithium, sodium and potassium, they react with cold water. How are they similar? Previously, in the previous question, the question specified difference, where one metal further down become more reactive, they react more vigorously and more violently. Here is how are they similar. If we look at the previous question as well, the reactive metal plus water give you metal hydroxide and hydrogen gas. So the fact that hydrogen gas is produced, you will see effervescence, you will see bubbles, all right? So there is gas being produced. So they say how are they similar? So how they're similar? All of them produce or form, whichever word you like. Straight to the point, they give off hydrogen gas. All right, how are they different as well? So all these three elements, lithium, sodium, and potassium, the way they react with water is they will float on the surface of water. So all lithium, sodium, and potassium, they float on water. They react on the surface and they might catch on fire. All right, they can catch on fire. They can catch on fire, but essentially they float on water. They can catch on fire is probably another observation already, or another similar kind of reaction. They float on water. As they react, then it will get smaller in size, and then the solution will become colorless. On to the next one. So this is a table on properties. So you got to think about structure and also bonding. This is from year 9 structure and bonding topic. So what do we know? Each letter may be used once, more than once, or not at all. You're looking for not a solid at room temperature. Room temperature is 25 degrees Celsius. As you know, melting is from solid to liquid. So at 25 degrees Celsius, you haven't melted yet because you require 119 degrees Celsius to melt. So at 25 degrees Celsius, this is still a solid. At 25 degrees Celsius, it is still a solid because you haven't melted yet. Minus 78, you already melted. By the time you reach 25 degrees Celsius, you are probably already a liquid, already melted. 857, again, your 25 degrees Celsius is there. Same for that, same for that. So haven't melted, haven't melted, haven't melted. This is the only one that have already melted by the time you reach 25 degrees Celsius. So the rest are solids, apart from this one, which is not a solid, meaning to say we need to use the letters and not just to say whatever we want, because we know how to read question. Next one, the substance that is a group 1 metal. Group 1 metal, they conduct electricity when solid. Okay, so this one, conduct when solid, this suggests that these are metals. Metals conduct electricity when they are solid, and conduct when melted, that's fine. It reacts with water, whereas this one doesn't react with water. We know group 1 metal reacts with water. Reactive with water. Reacts with water. So this one reacts with water must be group 1 and not this one where it's got no reaction with water. So we're looking at Z. Now give a reason, a meaning 1. So I can probably give 2 reasons. Not just because they are metals, because Y is also the metal. It has to be, is a metal. It conducts electricity when solid and molten, but it also reacts with water. So group 1 metal are reactive with water. Are reactive with water. It is a metal because it can conduct in the solid. That's what the question says, when solid and also when melted, meaning in liquid state. When you melt already, you become a liquid. So both of them conduct when they are solid as well as when they are liquid. So it is a metal, therefore can conduct when solid and also when molten and when molten. Alright, they just want one reason. I'm pretty sure this is the better reason than this, because by saying this, Y could also be the answer, but Y does not react with water. Now the substance that is an ionic compound, remember the properties of ionic compound, does not conduct when solid because no free ion. Does not conduct electricity when solid, only conducts electricity when aqueous means dissolved in water, or in liquid state, meaning when you melt it. Alright, so we are not looking for something that can conduct when solid, but we are looking for something that can conduct when it's molten. You see, does not conduct when solid, can conduct when it's molten, very high melting point, can dissolve in water. All of these will be your reasons for your choice for ionic compounds. In our case, we're going to choose X because they conduct electricity when molten, when melted, but does not conduct when solid because the ions are not free to move. It has got very high melting point because you need to break strong ionic bond due to the giant ionic structure. It's soluble in water as well, but we'll very focus on the melting point as well as the electrical conductivity, as those two are stated in your syllabus. All right, which one is the ionic compound? X. So what is your reason? Reason number one, ionic compound conducts electricity when in liquid state or when molten, not when they are solid. So X conducts electricity when melted, but does not conduct, meaning no conduction of electricity when in solid. All right, I could also say X has a high melting and boiling point. Oops, sorry, not melting point. According to the data in the table, because we can read melting point, this is considered very high melting point. So X has high melting point. All right, because we need to break strong ionic bond. We need a lot of energy to break strong ionic bond because it's ionic compound. So you have ionic bonds between the cations and anions. Moving on to the next question. So again, it's about lithium, sodium, and potassium. So not too surprising. Hopefully you can see that, group 1 chemistry type of questions, very, very popular. Descended meaning going down. So what happened? What happened to the melting point of the group 1 metals? Down the group, going down the group. Well, it's just stating, so it's not explaining. So we can say that melting point down the group decrease. So it's a trend that you must know, as stated in the syllabus. They get the melting point become lower and lower. Now, why do you call the group 1 metal as alkali metal? If you think about group 1 metal, they can react with water. They can react with cold water. They can react with water, or they can react with cold water to form metal hydroxide. And guess what? Anything that contains hydroxide therefore forms alkaline solution. Alkaline solution means your pH is above 7. Your pH is above 7, is greater than 7. So therefore, it is an alkaline solution because the hydroxide give you the alkaline solution where the pH is above 7. On to the next part, they react with chlorine. Chlorine is a non-metal. If you think about the periodic table, it's in period 3, but that's not what give it away. Group 7, that's what give it away as a non-metal. And they will get ionic metal chloride because metal on the far left of the periodic table, non-metal, non-metal on the far right of the periodic table. You're going to write a balanced symbol equation. Chlorine with potassium. Chlorine exists as Cl2 from your structure and bonding. Covalent bonding, one of the many simple covalent molecule stated in the year 9 syllabus, Cl2 plus potassium. K is not K2 because it's not a non-metal covalent compound. So K, and then they will form KCl. So this is the ionic compound that you get, K plus and Cl minus. So plus 1 and minus 1. When we do cross multiply, we cross multiply the value. So we do not cross multiply the ion or the charge, we cross multiply the value of the charge. So 1 there become 1 there. The value of the charge is 1. So I just bring down the 1. This means 1K plus and 1Cl minus. So the formula is going to be KCl just like that. Of course, they want the balance equation. I've got 2 chlorine. I've got 1 chlorine. So I put a 2 there. Now I have 2 potassium, but I only have 1 potassium on the far left here, so I need to add a 2 in front to balance my equation. Next one, this is a repeat question from previous similar question. How does the reactivity of lithium differs from potassium? Lithium is 2,1, whereas sodium is 281. This is 2881. As you can see, the valence electron, the 1 electron, is further away from the center of the nucleus, from the center which is the nucleus. Therefore, it's easier to be lost. Going down the group, your valence electron, easier to lose. easier to be lost. If you are easier to be lost, therefore you are more reactive because you are easier for you to lose electrons. So therefore lithium is less reactive than potassium because the lithium is further up in the periodic table in the group 1 compared to potassium. This answer will be correct if you say potassium is more reactive than lithium. It's the same way. State one way in which the properties of potassium chloride they mentioned just now is ionic compound. How is ionic compound different from covalent compound? We talked about two things previously. We talked about conduction of electricity for ionic compound. Covalent compound does not conduct electricity at all, even when solid or liquid or aqueous, and covalent compound has low melting point. So you can choose either one of these because they say state one way. So I could think about potassium chloride has high melting and boiling point. So potassium chloride has high melting point, melting and boiling point if I want to, but melting point would have been alright as well. But they say differ from, right? So I need to say but covalent compound would have low melting. Covalent compound will have, or has rather, covalent compound has low. High versus low melting and boiling point. If you want, you can talk about conduction of electricity. Potassium chloride does not conduct when liquid or aqueous, but they conduct when they are solid. Alright, so potassium chloride can conduct. So I can use KCl or you can use potassium chloride, whichever one you want. So potassium chloride conducts electricity. Conducts electricity when liquid or aqueous. Not when they are solid, but not when solid. But then I also need to mention about covalent compound. So covalent compound does not conduct electricity at all. Covalent compound does not conduct at all, even when they are solid, liquid, or aqueous. All right. Moving on to this set of questions on the last page of this tutorial. So sodium is in group 1. This is group 1 metal plus water. They will give you the metal hydroxide. Earlier in the question, they say why is group 1? Why is group 1 metal called alkali metals? Because they form metal hydroxide. Metal hydroxide has this OH minus. This is called hydroxide ion. Hydroxide ion is responsible for your pH being greater than 7. That is your alkaline, or that is your basic solution. And guess what? Going back to the name, you call it alkali metals because they dissolve, they react with water to give you metal hydroxide. Hydroxide ion give you the alkaline or basic solution. So there's the name given for group 1 metal. They are called alkali metal. Name the ion, cause it to be alkaline. They want name. You cannot give formula. You gotta give the name because the question say name the ion. If the question say give the formula, you cannot give the name. You have to give the formula. Now, when the alkaline solution which contain hydroxide, so if you have hydroxide ion, you plus ammonium. Ammonium is NH4 plus. Chloride is Cl minus. Ammonium chloride is going to be NH4Cl. If you think about your year 9 balancing chemical formula, plus 1 for the ammonium formula, minus 1 for the chloride formula. So you cross multiply the value of the charge is 1 there. You cross multiply the value of the charge is 1 there. So 1 of what? 1 of NH4 plus, 1 of Cl minus. Your formula is going to be NH4Cl. Not that it matters here, it's an ammonium salt. You're gonna get ammonia and you will get water. You will get water and you will get metal salt. All right, they want the colorless gas. This is liquid water. This is an aqueous solution. The gas is going to be ammonia. They want the name. Ammonia is NH3. NH3 is the formula ammonia as stated in year 9 structure and bonding. For covalent compounds, you must know how to draw the dot and cross for ammonia. Next one, describe the trend in melting point as well as the trend reactivity going down the group. Descending means going down the group 1. Your melting point will decrease going down group 1, but you will become more reactive. So reactivity increase, meaning more reactive metal going down group 1. As we said, easier to lose the outer shell electrons, easier to lose the outer shell or the valence electrons, more reactive metal down group 1, but the melting point will decrease. So this is just straightforward melting point decrease down group 1. Next one, last question, why sodium cannot be extracted by heating with carbon? If you think about the reactivity series, you have potassium, sodium, so it's poso-carbamazole. So potassium, sodium, calcium, magnesium, aluminium, zinc. So poso-carbamazole, so zinc, iron, but iron symbol is Fe, but you pronounce it iron. And then Zil, so it's lead, and then is hydrogen, and then is copper, silver, gold. So we know that carbon is roughly there. All right, so iron could be extracted by carbon. So iron could be extracted by carbon because we use carbon monoxide to reduce the iron 3 to iron 2. But then sodium is way too reactive. Sodium is way more reactive. Oh, actually, I think I'm wrong. Hang on. Carbon is there actually. Carbon is there. And therefore, since carbon is a more reactive species than iron, carbon can reduce iron like that. All right. And what happened with sodium is above carbon in the reactivity series. So sodium is above carbon in the reactivity series, and therefore you cannot do that. So very straightforward. Sodium is above carbon in the reactivity series. That's why you cannot do this. But iron is below carbon in the reactivity series. That's why we can get iron by reduction with carbon. All right, we're going to be talking about extraction of metals a lot more in the next tutorial. So yeah, make sure you finish out your work and you ask any questions related to what we have covered so far as part of your revision for your year 11 combined science chemistry. Thank you for watching. Follow me at ptet.chemistry on Facebook, Instagram, and Twitter, and click the button on the bottom right to subscribe to the channel.